for decades. You know, those dark streaks you see snaking down slopes on Mars. They've really been a mystery. And the initial idea, the one that got everyone excited.
Flowing water.
Exactly. Flowing water, maybe even meaning Mars, could be habitable today. Big stuff.
Huge. It painted this picture of a dynamic Mars, maybe with little niches for life.
But hold on, because this deep dive is looking at brand new research that sort of throws cold water on the water idea, actually.
It's pointing towards something much drier. Dry dust avalanches, essentially.
And this isn't just a small look. We're talking about a study that used machine learning to analyze, get this, over 86,000 high-res images of Mars.
That's right, a massive effort by researchers at Brown University and the University of Bern. It really changes the scale of how we can look at these things.
86,000. Wow. You just couldn't do that by hand, could you?
Not realistically, no. Not on a global scale like this. The machine learning was key to finding planet-wide patterns. They mapped over 500,000 of these slope streaks.
500,000 features. Okay, so the big question for us today, what are these things really? Why did we think water was, the answer for so long?
And what does this shift mean? This new paper in Nature Communications by Domus Valentinas and Valentin Bickel has some pretty significant implications.
Right. Let's dig in. Where did the whole water idea even start?
Well, it goes way back. We first started seeing these kinds of features clearly with the Viking missions in the 1970s.
Ah, Viking. The OGs of Mars landers and orbiters.
Yep. And even in those early images, you could see these darker lines running down steep slopes, hundreds of meters long sometimes. They looked like something had flowed there.
Visually, yeah, it's very suggestive, like a stain left by liquid.
Exactly. And then later, with better cameras, we found the RSLs recurring slope lineae.
RSLs, okay, what made them special?
They were seasonal. They'd appear during the warmer parts of the Martian year when temperatures got just above freezing in some places, and then they'd fade away as it got colder.
Oh, okay. So appearing and disappearing with temperature. That really sounds like water, doesn't it? Like melting ice.
Or maybe super salty brines. Salt lowers the freezing point, so maybe salty water could flow even in those cold Martian conditions.
Right, or maybe even moisture condensing out of the thin atmosphere.
That was another possibility, yeah. All these ideas pointed towards some kind of volatile, something that could change state with temperature, and water was the most exciting candidate.
Because water means, well, potential life. You can see why everyone jumped on that.
Yeah,
Imagine finding microbes kicking around in those damp spots.
Absolutely. The potential habitability angle was, and still is, a huge driver for Mars exploration. But, not everyone was completely sold on the water idea even back then.
Oh, what were the alternatives?
Some scientists suggested maybe dry processes could explain them, things like rock slides or maybe just wind-related phenomena. But the seasonal nature of the RSLs kept pulling people back to water.
Okay, so enter this new study with its massive data set. How did they use all of those images to test these ideas?
Well, instead of just looking at a few streaks here and there, they built that global map. 500,000 streaks mapped across the entire planet.
That's the power of the machine learning approach, right? Seeing the big picture.
Exactly. It allowed them to ask, do these streaks consistently show up in places where we'd expect water to be involved? Like, are they always on slopes facing a certain direction to catch sun, or in areas with big temperature swings, or where we know there's subsurface ice or hydrated minerals?
So they layered the streak map over maps of temperature, geology, humidity, wind, all that stuff.
Precisely. They were looking for statistical correlations. If water was the cause, you'd expect strong links to factors related to water or ice behavior.
And what did they find? Did the water theory hold up under that kind of scrutiny?
Actually, no. That's the big finding. They found a really striking lack of strong correlation between the streaks, including those seasonal RSLs and the factors you'd link to liquid water or melting frost.
Really? So not strongly tied to temperature swings or humidity?
Not in the way you'd expect if melting was the primary driver. They didn't consistently favor specific slope orientations where ice might linger or melt preferentially.
Huh. Okay, so if the data didn't point towards water, what did it point towards?
The strongest correlations they found were with areas that had above-average wind speeds.
Wind?
Yeah, wind, and also areas known for having significant amounts of fine dust deposition, places where dust tends to settle.
Okay, so windy, dusty areas are hot spots for these streaks. That sounds, well, distinctly dry.
It does. It fits much better with the dry mechanism.
So what's the proposed mechanism then? How does wind and dust make these long, dark lines?
The idea is that Mars is covered in layers of fine dust, right? And on steep slopes, the topmost, often lighter-colored layer can become unstable.
Like a little dust drift.
Sort of, and then
Yeah.
something triggers it, maybe a gust of wind, maybe a small vibration, and that top layer slides down.
Ah, like a mini avalanche of dust.
Exactly, a dust slide. And when that lighter top layer slides away, it reveals the slightly different, often darker material underneath. That's the streak you see from orbit.
Okay, that makes intuitive sense, like scraping off a thin layer of light powder to show the darker stuff below. But what causes these dust slides to happen? What's the trigger?
The study found a couple of interesting links. For the general slope streaks, they noticed they were more common near relatively recent impact craters.
Impacts, like meteorites hitting Mars.
Yeah. The idea is the shockwaves from the impact could travel through the ground and sort of shake loose the dust on nearby slopes, making it easier for it to slide.
Wow, okay. A cosmic nudge triggering a dust slide.
Seems plausible. And for the RSLs, those seasonal ones, they found those were more frequent in areas where we know dust devils are common or where we've actually seen evidence of small rockfalls.
Dust devils. So those little whirlwinds could be kicking off these streaks.
That's the idea. A dust devil passes over, or a small rock tumbles down, disturbs that delicate top layer of dust, and whoosh, down it slides.
So the seasonality might just be linked to when dust devil activity is higher, or when thermal stress causes more rockfalls, rather than when water melts.
That seems to be what the data is suggesting, yes. It connects the RSL behavior to known active dry Martian processes.
Okay, so, wow. This really reframes things, doesn't it? Those features we hoped might be little habitats are probably just dusty slopes behaving dynamically.
It's definitely a shift, and it has real implications for, how we think about searching for life and planning missions.
How so? What is the change?
Well, first off, it lowers the odds that these specific streak locations are prime spots for current life. If there's no readily available liquid water, it's much harder for life as we know it to thrive.
So maybe we shouldn't prioritize sending our next rover to land right next to an RSL, hoping to scoop up microbes.
It certainly makes those specific sites seem less biologically promising based on this evidence. Of course, Mars might still hold water elsewhere, perhaps deeper underground, but these surface features look less likely to be wet.
And what about planetary protection? Making sure we don't accidentally contaminate Mars with Earth life.
Right. That's a big deal. If these sites were potentially wet and habitable, they'd be considered special regions requiring extreme sterilization measures, maybe even making them off limits for landing.
Because you wouldn't want Earth bacteria getting into Martian water.
Exactly. But if they're fundamentally dry dust phenomena, the immediate contamination risk for those specific features is likely lower. It might make accessing areas near them slightly less complicated logistically, though obviously we always maintain very high standards of cleanliness for all missions.
Sure. It's interesting. Domus Valentinus, one of the authors, was quoted saying something about the advantage of this big data approach, wasn't he?
Yes, he highlighted how analyzing this massive orbital data set lets us test and potentially rule out hypotheses before we send expensive hardware to the surface. It helps focus the search.
Makes sense. You can narrow down the possibilities from orbit before committing to a ground investigation.
It's a much more efficient way to explore in many ways.
Okay, so let's wrap this up. The main takeaway here is that these famous Martian streaks, the RSLs included, which really fueled hopes for present-day water, they now look much more likely to be caused by dry dust avalanches.
Triggered by wind, impacts, dust devils, basically the everyday weather and geology of a dry, dusty Mars.
It's a pretty fundamental shift in understanding what's happening on the surface right now.
It is. Mars is still active, still changing, but maybe just not in the wet way we thought, at least not with these features.
Which leaves us with a fascinating thought, doesn't it? If something that looked so much like flowing water turns out to be just dust sliding around, what else might we be misinterpreting just based on how things look on Mars?
That's a great point. What other visual cues are we perhaps reading through an Earth-centric lens?
Yeah, what subtle, active geology are we missing? What completely different processes might be shaping the red planet that we haven't even conceived of yet? Makes you wonder what other Martian surprises are waiting for us.